Okay, this is our setup for our pull-back car lab. You can see that I've got the short piece of track right here. There's 1, 2, 3 of the long pieces of track. The other track's there, but then I put something to mark the end of the third piece and the beginning of the first piece. So here's our 90 centimeters that we have. So no need to measure it. It should come out to be 90 centimeters, and that's going to be a constant. Now when you run your car, you want to be consistent on your trials. So I usually do this. I'll start with the car back here, pull it back to this point, make sure our track is lined up still, and then we'll run our stopwatch from here to that point. And that's what you'll get for your time. So you'll probably need help running your stopwatch, but your timing from here when you release it to when it gets to there. All right, so you have your data, your time for each of your pullback trials. Now you got to go through and calculate your acceleration and your velocity. We're going to be using 2 of our triangles that we had in a previous activity. So again, our first one is to get our acceleration, and so this was our triangle. It's our distance, our time, and our acceleration. So we're actually solving for the acceleration. So half of the acceleration is equal to that distance divided by the time squared. So the distance in this problem was always going to be that 90 centimeters. Okay, so we've got 90 centimeters that we're going to divide by your time. And like for me, I had a trial that had a time of 0.90 seconds. Okay, so again, this is my time. So this is what you would be using right here is the time right there. And that's equal to half of my acceleration. So now when I go through to do my calculation, I'm going to grab my calculator here. Okay, I'm going to take my 90, I'm going to divide it by my 0.9, and I'm going to divide it by 0.9 again to get that square thing. Now that's going to give me what half my acceleration is. So I need to get rid of this half, so I'm going to times it by 2. So my acceleration comes out to be 222 centimeters per second squared. So that's how you go through and figure out your acceleration. Now once you go through that, you want to get your velocity. Okay, so your velocity triangle is going to be your acceleration times time is equal to that final velocity. Okay, or that change in velocity, but our initial velocity is 0, so really this is going to be our final velocity. So our final velocity is equal to the acceleration times the time. Well, our acceleration was 222 centimeters per second. My time was 0.90 seconds. So I'm just going to times that by 0.9, and that comes out to be that my final velocity is 200 centimeters per second. So I'm going to go through and find out all those velocities, and then I'm going to average those velocities on the data table.